Hi guys, please make sure that you have your guided notes for chapter 1. And welcome to chapter 1, statistics. We're going to start by going over some vocabulary here. So to start us off, statistics is the science of planning studies, experiments, obtaining, organizing, presenting, analyzing, and interpreting the data, and then drawing conclusions. So this is important because we're not actually going to be doing a ton of math in this class. We are going to take data and we are going to look at it, and then we're going to interpret it. And that's important because computers and calculators can do a lot of stuff with data. They can give us a lot of numbers. We don't really have to do the math on that. What's important is, can you as a person read through scientific, political, social science studies and understand if it's a good study or a bad study? And can you interpret what their data is actually saying? That's what computers can't do. That's what we need to be able to do. A population is an entire collection of individuals about which the information is sought. So part of looking at a study to see if it's good or bad is going to be seeing, does their sample, does their study actually represent who they say it represents? To that effect, they need to take a good sample. A sample is a subset of the population containing individuals that are actually observed. So we have this huge population, we're going to take some out. Those are the sample, those are the people that we either ask a question, we observe, we ask them to take this medication. They're the people that we actually collect the data about. And then we say, okay, I have this sample and I have all their data, and I'm going to say that they represent, I can say that what happened to them would happen to everyone else in the population. Or you can take a census. A census is if you collect information about literally everyone in the population, so that you know for sure what the true value is. To try to get a good sample, there are multiple methods. The first one is a simple random sample. And we are going to use the notation small n, the small n letter, to represent the number of people that we choose in any sample that we take. So a simple random sample is like if I pull names out of a hat, or use a raffle drum, or spin around and point, right? It's some method that you use to try to be random. Some other methods, this one's called the sample of convenience, and this is basically a bad sample. That's what we call it. A sample of convenience is, well, I asked some people around. I asked people in my classes. I sampled friends and family members, right? It's something that's not a well-defined random method. Asking customers waiting in a line, asking people in your neighborhood, whereas your neighborhood may systemically differ from everyone you want to talk about in some way, right? So we want to make sure that we're sampling from various different backgrounds, or at least we're trying to be random about it to minimize any systemic differences that would separate our sample from the population. In systematic sampling, this is another sampling technique, systematic sampling. Every kth item is picked. So that's like every 50th box of cereal, every third person in line, every fifth bicycle, right? So we're looking at trying to be random by being systematic. And that's actually a much better way than just trying to pick at random, because humans are very bad at being random. If I went out and tried to pick people at random, I might pick people that I look around and I feel more comfortable approaching them. And that would be a subconscious thing. It might not be something that I'm trying to do, but I might accidentally create bias by saying, no, I'm just going to do every third person that walks by. That way it takes away any internal bias I might have and just picks those people. So it's actually much more scientifically random to be systematic. Cluster sampling is a very interesting sampling technique because first you break people into groups. And then you say, okay, maybe I'm doing this by cell phone providers, right? So group 1 is Verizon, group 2 is Sprint, group 3 is T-Mobile, and group 4 is Sorry, ran out of ideas, but they're different cell phone providers, right? And I'm going to say, okay, so I'm going to sample this group and this group. And I'm just going to ask everyone in those two groups the question. And then I'm going to say that that's representative of all the groups 1, 2, 3, 4, 5, and 6. This can be a very good method and can actually help like cut out some external factors that might influence your data. However, if you are not very careful about how you split these people into groups, you could actually be creating more bias. So cluster sampling is very interesting, but you really got to have a reason why you're using cluster sampling, or it can actually hurt your data. Another method is called stratified random sampling. And this one can get a little confusing because it starts out exactly the same as cluster sampling. We're going to break them into those same groups. But this time, instead of grabbing groups 1 and 4, I'm going to grab a little bit from every group. And this is a really good method if you have subgroups in your population and you want to make sure all those subgroups are equally represented. You can do it that way. So really important that you notice cluster sampling and stratified random sampling are very similar. Don't mix them up. They are very different. In cluster sampling, you grab whole clusters, and in stratified sampling, you grab a little bit of each cluster. So both of them are very similar. You start by breaking them into groups, but we want to make sure that we understand the difference between cluster sampling and stratified sampling. Another method to collect data is voluntary response samples. Voluntary response samples are common because it's one of the easiest ways to get large groups of samples. You see pop-ups, you see questionnaires at businesses. These are voluntary response samples. And while sometimes it's the only way you can get that sample, the downside is they tend to be very biased. You tend to have people with very strong opinions, people who are very happy or very unhappy. And in fact, people who are angry are much more likely to respond to these because they're feeling visceral anger and they want to vent it. Versus someone who's very happy might submit something, but they might not. They might just enjoy their happiness. So you tend to get negative opinions over positive opinions. A representative sample reflects as closely as possible the relevant characteristics of the population under consideration. So this is if you took a good sample. If you take a good sample, it is a representative sample. So just a little thought experiment. What would you do to try to make sure that you accurately sampled to get the average height of an ASU student? What kind of sampling technique would you use? How would you do it? Where would you go to obtain this information to make sure that it is unbiased, that it is in fact representative? Give it a thought, see if you can write down some thoughts, and we should discuss that in class. Statistic versus parameter. So got some more vocab going on here. A statistic is what we're actually going to be able to compute. We're going to have our sample, we're going to take numbers from our sample, and we're going to compute a statistic. A parameter is a measurement that describes the characteristic of a population. You can only get an exact parameter from a census. Otherwise, we might take our statistic and say, well, I took my sample, and here is the average I got from my sample. This is a statistic. I'm going to take the statistic and say, I think this represents the entire population's average, but that would be a parameter, right? So I'm going to say that my statistic can say something about a parameter. And we're going to be doing a lot of that in chapters like 7 and 8. So I want you to read through each of these following scenarios. Please pause the video and go through these scenarios, and I want you to identify the population of interest, the sample, how did they sample it? What was the sampling scheme used? And are there any issues? See if you can find any issues with the sample being representative. Is there something that they could have done better, something that they did wrong? Or is there some way that they that you just have questions about, right? That they needed to clarify to make sure that they did their study correctly. Making sure you pause the video. Okay. So part A here, to estimate the average consumption in ounces of coffee per day at a particular coffee shop, the order of every fifth customer is recorded to be analyzed later. So the first thing we want to talk about is the population. So the population here should be the customers of this particular coffee shop, okay? We only sampled people at this coffee shop, so we can't say that this applies to other people. And we want to know, how do we know that that's what the population should be? So we want to say that the problem states at a particular coffee shop. So we're thinking that is what the researcher wanted to obtain. What's the sample for this problem? Every fifth customer at the coffee shop. So that is who the researcher recorded, right? The order of every fifth customer is recorded. And for this class, we're going to be doing a lot of identifying populations and samples because they need to be part of us interpreting our data. So highlighters, very useful tools. If you're looking at your notes and you're like, you know what, I'm going to color code this. I'm going to color this one, the sample part here, I'm going to color it pink, and I'm going to highlight how I figured that out. Or underline it with that color. There's a lot of good things you can do to make sure that your notes are really helping you out before exams for this class. So what sampling method here was systematic sampling? How do we know? Because systematic sampling is every kth subject is sampled, and in this case, it was every fifth customer. And are there any issues with the sample being representative? Not necessarily, but maybe you thought of some ideas because this question is pretty vague. So maybe you have questions about what time of day this was sampled. That makes a big difference in coffee shops. What day of the week? A Monday and a Saturday can look very different at a coffee shop. So there are questions that you could have about the sampling technique that may say that this may or may not have been a representative sample. Problem B, a physician is studying how exercise affects the sleep habits in US adults. She divides all her patients into 8 distinct age groups, blah, 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 blah. Then she randomly selects 2 of the 8 age groups and includes all the patients in each of the selected age groups to be part of the sample. And I'm going to take a quick break here to talk about if you did not pause the video and come up with the answers on your own before I put these answers up on the screen. So there is research that shows that students who try to formulate the answers on their own and then are corrected or verified are actually going to retain that information a lot better than someone who's just told the answer. And that has to do with the amount of effort put in to actually connecting those neurons together. So if you have not paused the video and filled out the answers yourself, please do so now. All right, so looking at problem B here, our population is US adults. How do we know? The researcher states that they are looking at the sleep habits of US adults. So right here, it says sleep habits in US adults. So that's where we're getting that number, or sorry, where we're getting that information. So make sure that you can identify that. What is the researcher saying? Who is this supposed to represent? Our sample here is the 2 age groups she picked. So she split people up into these different age groups, right? And then she selected 2 of the 8 age groups. So that's who she asked. So two decades worth of her patients. Randomly selects 2 of the 8 age groups. What sampling method is this? Cluster sampling. How do we know? Cluster sampling is randomly selecting groups and then recording everyone in the selected group. So she picked 2 of the age groups and asked everyone in those groups. That's cluster sampling. Are there issues with the sample being representative? Yes. This doctor's patients do not represent all US adults. This is convenience sampling. Not only that, but this way that she clustered them into age groups means that depending on which two clusters she picked, she could get some very strange non-representative data. So there's some weird stuff going on in this study that you would be like, I don't feel like I can trust your results. All right, problem C here. At Made Up College, there are 120 freshmen, 90 sophomores, 110 juniors, and 80 seniors. A school administrator selects a random sample of 12 freshmen, 9 sophomores, 11 juniors, and 8 seniors by rolling dice and choosing the students off the enrollment list. They then interview the students on study habits. So what is our population in this case? Students at Made Up College. How do we know? They state that as the population of interest right there in the beginning. Right, at Made Up College. And they are looking to interview the students on study habits. Our sample was 10% of each class. I don't know if you caught that reading it through the first time, because it's just, if you didn't notice that, they seemed like weird numbers, right? But 10% of 120 is 12, 10% of 90 is 9, 11 is 10% of 110, and 8 is 10% of 80. So it was 10% of each class year. So the sampling method here would be stratified / simple random sampling. So I would accept either one of those, but it's kind of a mix of both, right? So first they split everyone into groups, freshmen, sophomores, juniors, and seniors. So that's the same way we start off with cluster sampling by breaking people into groups. But then they wanted 10% of each group. So that's stratified, taking a little bit of each group. And then in order to pick who in each group they were going to pick, they used the simple random sampling of rolling dice, just some method to help you be random. So the random system of a dice roll to help humans be random. Everything seems okay at a first glance. I don't see anything wrong with this, but it is still vague. So if you thought of something definitely worth sharing, could be interesting to hear. All right, and this brings us to discussion 1.3, and I would like to go over this with you in class. So go ahead and if you want to write down your answers ahead of time, and then we can discuss those in class.